At exactly 8:30 a.m. on May 19, 2025, an SBU operator wearing FPV goggles received the authorization he'd been waiting for: send it. Within seconds, a Ukrainian-built quadcopter drone carrying 3 kilograms of high explosives began a 35-kilometers journey across the Black Sea to eliminate one of Russia's most important surveillance assets that would help Ukraine take back the Black Sea. The operator, call sign Soil, was positioned in a concealed bunker 35 kilometers from the target on Snake Island. His drone was a standard 10-in-frame FPV quadcopter built from Chinese components in a Kiev workshop just days earlier. But this wasn't a racing drone anymore. Zip tied to its belly was a custom explosive device meant to destroy this radar and eliminate any personnel within a 5M radius. The target coordinates had been programmed into his ground control system hours earlier. The Neva radar installation on Boyko Tower Alpha, one of Russia's seized gas platforms in the Black Sea. This wasn't just any radar. The Neva system provided 45 kilometers detection coverage that had been hampering Ukrainian operations for months. Taking it out would allow Ukrainian forces to move about this area of the Black Sea much more freely. The FPV drone system he was operating represented the democratization of precision warfare. A $500 racing drone transformed into a guided missile through Ukrainian ingenuity. The quadcopter's 4 brushless motors spun up to 20,000 revolutions per minute as the pilot initiated takeoff from an improvised launch platform hidden among the coastal reeds. Unlike traditional military drones, FPV systems provide real-time video feed through an analog transmission that resists electronic jamming. Soil could see exactly what his drone saw through the VR-style goggles strapped to his head, creating an intimate connection between pilot and weapon that made FPV drones devastatingly accurate against point targets. The flight profile was carefully planned to avoid Russian detection. Rather than flying straight toward the target, the drone would follow a zigzag pattern like this, staying below 50 m altitude to remain under radar coverage. At 65 kmeh, the 35 kilometers journey would take just over 45 minutes due to the zigzag pattern the drone would have to take to avoid detection. As the drone lifted off and began its approach toward Boyko Towers, Soil could see the Black Sea spreading out below through the drone's camera. In the distance, the gas platform rose from the water like a steel island, bristling with Russian equipment and personnel who had no idea what was coming towards them. At 9:15 local time, Soil's FPV drone crested the final wave, and the Boyko Tower platform came into crystal clear view through his goggles. The massive steel structure rose 40 m above the Black Sea, and there, mounted on the platform's highest point, sat his target, the Neva radar system that had been tracking Ukrainian operations for months. The Neva radar wasn't just any surveillance equipment. It was one of the few legacy Soviet systems that actually worked well. The K-band system operated at a frequency of 35 gigahertz, with a rotating antenna array that could detect aircraft and surface vessels at ranges of up to 45 kilometers. More critically for Russian forces, it could track 200 targets simultaneously and provide targeting data to weapon systems positioned throughout the northwest Black Sea. But despite its engineering, the radar system couldn't survive an explosive drone to the face. The 3 kilograms strapped to Soil's drone might not seem like much, but it would be absolutely devastating when directed against delicate transmitters, receivers, and waveguide systems. Through his goggles, Sok could see Russian personnel moving around the platform's lower levels, completely unaware of the threat approaching from the northeast. The NEA radar continued its methodical rotation, each sweep bringing it closer to potentially detecting the incoming drone. But FPV quadcopters have tiny radar cross-sections roughly equivalent to a large seabird, making them nearly invisible to most detection systems. At 800 m from the target, Sohail began his terminal approach. The beauty of FPV systems lies in their precision. Unlike artillery missiles that rely on GPS coordinates, FPV pilots can make real-time adjustments up to the moment of impact. Soil could see exactly where he wanted to strike, the junction between the radar antenna and its control unit, the sweet spot that would maximize damage to both mechanical and electronic components. The drone's camera showed the NEA installation growing larger in his field of view. Soviet engineers had built the system to withstand electronic jamming and environmental extremes, but never designed it to survive a direct explosive impact. The radar's protective housing was aluminum sheeting intended to keep out salt spray and rain, not high explosives traveling at 60 km/h. At 200 m, Russian personnel on the platform finally spotted the incoming drone. So could see them pointing and shouting, but it was far too late. The quadcopter was moving in too fast, and the range was too close for any defensive action. One technician reached for what looked like a rifle, but the drone would impact in less than 10 seconds. At 0920, Soyuz FPV drone struck the Neva radar system's antenna assembly with devastating effect. The explosive charge detonated instantly on contact, sending fragments of aluminum, steel, and electronic components flying across the platform. The explosion wasn't large by military standards, but it was perfectly placed. The radar's delicate waveguide system was shredded, its transmitter destroyed, and its rotating antenna mechanism completely severed. In one precisely delivered blow, a drone that cost less than an annual Netflix subscription eliminated one of Russia's best surveillance capabilities. While smoke rose from the destroyed Neva radar 80 kilometers away, a far more devastating weapon was beginning its approach to the Boyko Towers. Although not 100% confirmed as of the making of this video, many suspect it was this weapon that was heading towards the platform. The Sea Baby drone, cutting through the Black Sea swells, represented Ukrainian maritime warfare at its most sophisticated. A 6 m long unmanned surface vessel carrying nearly 1 ton of high explosives toward the Russian-occupied gas platform. Unlike the improvised FPV drone, the CB was purpose-built for destruction. Developed by Ukraine's SBU facility for attacking hardened maritime targets, this sleek gray vessel looked more like a high-speed patrol boat than a weapon of war. But hidden beneath its unassuming exterior was 1,000 kilograms of military-grade explosives, enough destructive power to level a city block. The warhead design of the CB was a masterpiece of explosive engineering. Rather than using a single massive charge, the CB's payload consisted of multiple shaped charges arranged around the bow section. This configuration created what engineers call a sympathetic detonation effect. When the primary target exploded, it would trigger secondary charges in sequence, creating a prolonged explosion that could demolish reinforced concrete structures. The explosive itself was a mixture of RDX and TNT, providing a maximum blast effect combined with sustaining temperatures exceeding 3,000 degrees C. When detonated against the Boyko Tower support structures, this warhead wouldn't just damage the platform. It would create a sustained fireball that would melt steel and turn concrete to powder. And despite its name, the CB definitely wasn't crawling towards the target. The propulsion came from twin 200-horsepower inboard motors driving water jets, which allowed the CB to reach speeds of 49 knots while maintaining a low profile on the water. The twin-engine configuration provided redundancy even if one motor failed. The drone could still complete its mission on the remaining power plant. Navigation was handled through a combination of GPS, inertial guidance, and real-time satellite communication. With additional fuel tanks, the CB could operate autonomously for its entire 1,000 kilometers range, but human operators maintained control through encrypted satellite links for precision strikes like this. This allowed for real-time course corrections and target selection up to the moment of impact. The drone's design prioritized stealth and survivability. Its low-profile hull kept it below most radar horizons, while the gray paint scheme made it nearly invisible against choppy sea conditions. More importantly, the CB incorporated multiple redundant communication systems. If Russians jammed one frequency, the operators could switch to alternate channels without losing control. What made this particular CB especially dangerous was its mission profile. Unlike previous attacks against moving targets like warships, the Boyko Tower was stationary and well mapped. The operators had detailed intelligence about the platform structure, including the locations of storage facilities, living quarters, and support columns. They knew exactly where to go to do maximum damage. As the CB approached its target at 45 knots, its warhead represented the culmination of Ukrainian innovation in asymmetric warfare. 1,000 kilograms of precisely engineered explosives were about to demonstrate why Russia should get out of Ukraine's swamp. At 9:15, the CB drone was 30 kilometers out from the Boyko Towers and closing fast. Through its high-definition camera system, SBU operators could see the gas platform growing larger on their screens. Black smoke still rising from the destroyed naval radar system. But their target wasn't the radar. It had been eliminated by the FPV strike. Their mission was to destroy the platform itself to ensure it could never function as a Russian military outpost again. The approach vector had been carefully calculated to maximize surprise and minimize Russian defensive capabilities. With the naval radar destroyed, Russian forces on the platform were effectively blind to surface threats. Their remaining detection capability consisted of their Mark I eyeballs and whatever handheld radios they could use to call for help. But help was over 100 kilometers away. Through the CB's camera feed, operators could see the full scale of the Boyko Tower complex. The platform consisted of multiple levels connected by a steel framework with storage facilities, equipment rooms, and living quarters distributed across different sections. Russian forces had converted the original gas extraction infrastructure into a forward operating base, complete with communications equipment, defensive positions, and supplies for long-term occupation. The CB's autopilot system was making hundreds of micro-corrections per second to maintain optimal approach speed and heading. Unlike human pilots, the drone's navigation computer could simultaneously process GPS coordinates, inertial guidance data, and visual targeting information, all while maintaining a perfect course toward the target. At 0935 and 10 kilometers out, the CB activated its terminal guidance systems. The drone's electro-optical camera package locked onto the platform's main support structure, specifically the junction between the drilling platform and the accommodation block where Russian personnel were housed. This wasn't random targeting. Ukrainian intelligence had determined that destroying this specific structural point would cause the platform to tumble into the sea. The CB speed had increased to maximum velocity, 49 knots or 90 km/h. At this speed, the 6M long drone had become a 6-ton projectile carrying 1,000 kilograms of high explosives. The kinetic energy alone would be devastating, but combined with the massive warhead, the impact would be absolutely catastrophic. Russian personnel on the platform had finally spotted the incoming threat. Through the drone's camera, SBU operators could see figures running across the platform's deck and pointing toward the approaching vessel. Some were grabbing rifles, others shouting into radios, but their actions were futile. The CB was now less than 5 minutes from impact, and no weapon system on the platform was capable of stopping it. The platform's defensive preparations were pathetically inadequate for this threat. Russian forces had some small arms and perhaps a few machine guns, but these were designed to repel boarding attempts by human attackers, not high-speed drone strikes. The CB's low profile and incredible speed made it nearly impossible to engage with conventional weapons. At 2 kilometers from the target, the CB was committed to its final approach. 1,000 kilograms of explosives were about to transform the Boyko Tower from a Russian military outpost into a twisted wad of metal. At 0950, the CB drone struck the Boyko Tower's main support junction with the force of a freight train. The shaped charges arranged around the CB's bow section focused the explosive energy directly into the platform's structural supports, creating a demolition effect that engineering textbooks would describe as catastrophic structural failure, but what I would call blown the F up. Within the first second of detonation, temperatures at the blast center exceeded 3,500 degrees C, hot enough to melt the steel framework that held the platform together. The accommodation block, where Russian personnel had been housed, disintegrated. Its prefabricated walls and floors vaporized by the sustained explosive burn. Anyone inside had no chance of survival. But the destruction was just beginning. The Boyko Tower had been designed as an integrated system, with each component supporting the other. When the Siebes warheads severed the main structural connections, it triggered a cascading collapse that brought down section after section of the platform. Storage facilities filled with equipment and supplies added fuel to the growing fire as their contents ignited and exploded in secondary detonations. The platform's fuel storage tanks containing diesel for generators and equipment began rupturing in sequence. Each tank explosion sent fresh flames hundreds of meters into the air, creating a pillar of fire that could be seen from space. The smoke plume rose over 1,000 m into the sky, a visual monument to the attack's effectiveness. Within 5 minutes of the Siebes impact, the entire upper structure of the Boyko Tower had collapsed into the sea. What had been a multi-level platform supporting Russian military operations was now a twisted mass of steel and concrete jutting from the water like the ribs of a massive corpse. The accommodation blocks, storage facilities, and equipment rooms that had housed Russian personnel and supplies were gone, replaced by debris floating on oil-slick water. The few Russian personnel who had been on the platform's lower levels and survived the initial blast were now trapped on unstable wreckage with no possibility of rescue. Help was hundreds of kilometers away, and the fires burning on the remaining platform sections made helicopter evacuation impossible. Ukrainian satellite imagery captured the scene 2 hours after the attack where the Boyko Tower had once stood as a symbol of Russian occupation. Only burning wreckage remained. The platform that had served as a forward surveillance post and logistics hub for Russian operations in the northwestern Black Sea had been completely demolished by 2 Ukrainian drones that cost less than 2,200 copies of Skyrim. Bye for now.